This is lesson 2.2, reason using properties from algebra. And if you're following in the textbook, it's pages 97 to 100. We've talked about these properties in class, but I'm just going to give you the notes. So the addition property of equality says if you have two quantities that are equal to each other, then if you add the same quantity to both sides, you are not changing the truth value. So whenever you add something to both sides of the equation, you are using the addition property of equality. Now, we've seen this when we've solved equations in class, but in geometry, this could also look like adding segments. So if you have two quantities, AB equals CD, and you're adding, let's say, BC to both sides, this is still the addition property of equality. And because you're comparing quantities with an equal sign. In the next lesson and moving forward, we're going to see how this is different from properties of congruence, where those properties are used as reasons when we are looking at statements that are congruency statements, so they don't involve an equal sign. But anytime you have an equal sign, you can use these properties. The second one is the subtraction property of equality. So if you have two quantities that are equal to each other, then subtracting the same amount from both sides does not change the truth value. And just like I did with the addition, you can have the same example, but subtracting BC from both sides, and it's still the subtraction property of equality. So this is the quantity that I'm subtracting from both sides. Multiplication property of equality says two quantities that are equal to each other. If you multiply the same quantity to both sides, you do not change the truth value. And in this case, we're multiplying C. Now, you can, in geometry, I guess this could look like if you have two quantities that are equal to each other, and maybe you're doubling both segments. So you can have these properties apply to especially when we start doing proofs, we're going to see statements that involve more letters than numbers. Division property of equality says if two quantities are equal, then dividing by the same quantity to both sides does not change the truth value. And the distributive property is if you have a number as a coefficient times an expression, which means there's more than one term, with more than one term. So a binomial, that's the term actually. So if you have a binomial, okay, times a coefficient, then you can say A times B plus C is equal to AB plus AC. Okay, the distributive property. The substitution property says if A equals B, then you can substitute A in place of B. Okay, or vice versa. It depends on how you read it, because you could also say B equals A. So you can substitute, if A equals B, then you can substitute A in place of B or B in place of A. So anytime you have substitution, if you are given x equals 3, then find or evaluate 2x plus 3 is usually when you substitute. So it's usually when you're given two quantities that are equal, and then you're replacing one of them in a separate equation. So that's the substitution property. I keep saying that because it's very similar to transitive property, but it's not the same thing. So the reflexive property says if A is a real number, so by real number, I mean whole numbers, irrational numbers, rational numbers, decimals that go on forever, repeating decimals, all of those are considered real numbers. So if A is a real number, then A is equal to itself. So this is sort of a weird property, and we'll honestly see this in our triangles unit more than now. But any quantity is equal to itself. That is a reflexive property. So you probably have seen it when you're checking your solutions, like when you solve for X and you have to go back and check, and you get the same number on both sides. That's the reflexive property. When you're solving an equation and the variables cancel out and you're just left with two numbers on both sides of the equation, and that means there's infinite number of solutions. That's also where you've probably seen the reflexive property, when you have two quantities that are equal to each other. Symmetric property says if A equals B, two quantities equal, then B equals A. So you're just sort of switching the position of A and B. One way is to think about that as 2x plus 10 plus 6 equals 10 is the same as 10 equals 2x plus 6. Okay, these two are the same thing. That's the symmetric property. The transitive property, which talked about in class, is if A equals B and B equals C, then A equals C. So in the transitive property is two separate conditions. There's usually two equations that have something in common, and then they're equal to something else. That's how you know it's the transitive property. Okay. So, using the properties of equality now, they can be used to justify steps in solving an equation. So, you do that by writing a proof. So in class, we saw a proof as a flowchart, but now you can also see a proof as a T-chart. So a two-column proof. The left-hand side of the proof lists the statements or steps. The right-hand side, you have the reasons that justify the steps. Now, what can we use as reasons? We can use all of the properties that I just discussed above. One that isn't really a property, but you will use as a reason is simplify. So when you're combining like terms, to explain what happened, your justification would be, oh, I just simplified. And combining like terms is like a specific form of simplification. There's various ways you can simplify an equation, but this is also comes up as a reason. We can use postulates. So angle addition, segment addition, and all of the postulates with planes and lines can be used as reasons. Theorems, which the only one we've really talked about is the Pythagorean theorem, but we are going to add to that list. There are some theorems that are coming up going into this next class, but definitions can also be used as reasons. So in this T-chart here, you're given some information, you're asked to prove something. The left-hand side's the statements listed here. are the statements, and here the statements listed here are the reasons. So I guess all of them are statements, but they also match up. So every statement and reason needs to match up. And you always start with a given. So 4x minus 1 equals 27. And to go from step 1 to 2, you can see you add 1 to both sides. So my reason that I can use that helped me go from step 1 to step 2 is the addition property of equality. And then to go from step 2 to step 3, you divided both sides by 4. So that is the division property of equality. Okay, the second example here, again, you start with a given, and to go from the first statement to the second statement, or the first step to the second step, you subtracted 2 from both sides, and that is the subtraction property of equality. And then to go from 2 to 3, you multiplied both sides by -6, which is the multiplication property of equality. Okay. Now the last one here is blank, so the only time I'll ask you really a completely blank proof is involving algebra. For geometry, as a bonus, I might ask you to do a blank proof, but again, there's so many reasons and that you kind of need to know, not memorize, but be able to recognize, that these will mainly be fill in the blank as we get into more complicated proofs. But with algebra, I can ask you to do a blank proof. So again, you start with the given. And I know I want to undo the division here. So I'm going to multiply both sides by 2, which is going to get rid of the fraction here. And my justification is the multiplication property of equality. Then I know I'm going to add 1 to both sides. So I get 5y equals 15. And that is the addition property of equality. And finally, my final step is to divide both sides by 5, which finally gives me y equals 3, and that is the division property of equality.